just a quick video to show you how Luos works and what it's capable of. So I'm going to demonstrate it to you by making a small product which is connected by Calam, and I will make it using a lot of boards because this is the purpose of Luos, how to manage and deal with a lot of boards into a device. So to make it, I'm going to use small boards we are using for demonstration, and we can just add a lot of boards like that into a network, and we have different kind of sensors or effectors for on demonstration. So in Luos, we have two kinds of services. We have driver services allowing to access to hardware. So those specific services can be moved easily into different boards because it relies on specific hardware. On application services, which don't depend on any hardware, just use driver services to work. Those services manage the behavior of the machine and can be moved on any board into the device and can be easily reusable into any kind of Luos product. So Luos allows to put as many as you want services on any kind of board. And this specific one, which is a motion sensor, I put only one service, which is a driver service, allowing me to access to this motion sensor. In this one, which is an RGB LED, I put two services, one driver allowing me to access to the LED, and another one, which is an application one, allowing me to access the motion sensor values to make the LED blink when there is a movement. So to make it work, I just can plug those boards together like that. And here we are passing the network through this wire. And I will add a new board just to, with a USB on it, just to power my system. And I'm gonna come back to this specific board later because we are using it for more things. So when I plug it on the power, Luos made a detection. The detection just is based on the physical position of all the boards onto the device and create data structures called routing table, allowing any boards to access any service of any boards accessing to any other service of any board on the device, exactly as if they were all located into the same program on the same board. So as you can see, I have a really basic alarm. So if I stop moving, the LED stops blinking, and if I move, the LED is blinking. This is really basic, but for now, it's not really usable into a bike because we can't stop it. To be able to stop it, we'll need to add a new features allowing me to just control the alarm. So to make it, I'm going to use a new board. This board could be made by someone else or another team or another company. And this board, which is a button board, I put two services. One, which is a driver allowing to access to this button, and another one, which is an application constantly monitoring this button to start or stop the alarm here. So to add these new features into my device, I just can plug it, and Luos just deal with hot plug. And we have different kind of scenarios to manage the hot plug depending on the product, on the best strategy to use depending on the product. So now I just had this button on every other board. Just know that there is a new button in this specific position able to do this, and this service. So now when I push this button, as you can see, the alarm is still running. And when I push this button, the LED turns white and the alarm just stops. And if I push it again, the alarm goes back. So we have a really basic behavior separated into small, tiny programs. We don't have any master here. And those tiny programs just use concurrently different resources into different boards of the system. And we can continue to develop the bike like that. And when it comes to go to industrialization, designers will need to reduce the number of boards of this product here. And when they do it, they only have to change the drivers. They don't have to change anything into the behavior and the application of this product. So now let me talk to you about this board, which for now I'm just using it to power my system. But as you can see, this is exactly the same board with an USB shield on it. And in this board, I put one service, which is a specific service called the gate. And this specific service translates everything happening into the embedded side into a JSON format and stream it into any communication way, such as Wi-Fi, Bluetooth, or in this specific case, USB. So let me show you how I can take control of all this device into a Python code. So of course you can use this JSON into any kind of machine or server, into any kind of languages. In this case, I'm going to use my computer with Python. The interesting line here is this one. I'm going to use PyOS, which is the library we made to simplify the connection through the Python to our boards. So here in this line, I'm just connecting to my USB ports and creating a bike object. And this bike object will have all the capabilities of my embedded device. So if I run this piece of code here, as you can see, we can just see the routing table, so the position of all the boards into the device and all the services provided by all the boards. And I can use all those services like variables into Python. And to demonstrate it, here I just display a small 3D bike and I link the orientation of this 3D bike into the orientation of my sensor. So when I move my sensor here, as you can see, the bike following my movements. And I can do it the other way. Here I can use my bike object and I can access to a specific service called start control, which is the service allowing me to start or stop the alarm. And I want to change the state to false to stop the alarm. So when I execute this piece of line or code here, as you can see, the alarm just stop. And if I want to run it back, turn it on back, I can just push the button again. The interesting thing here is when you develop a driver or any kind of service into the embedded side, you don't have to think about how anyone can access it through any other boards or any other machine, such as server or computer or on any kind of language. You just do it straightforward. You don't have to think about it. And this is really interesting for a connected device and with a lot of different skills needed to develop a product. So I hope this demonstration just make it more clear for you, and I hope to see you soon. Bye.